All right. Welcome, everyone. I'm Mary Watson, Director of the Coastal Resilience and Sustainability Initiative. I'm delighted to welcome everyone to this, our second in our series of events for the fall. And today we're going to launch into the first of two lightning talk sessions, the purpose of which is to help everyone who's signed on to be part of this get to know who else is in the community and start to broaden our networks and build connections across the campus. I'm not going to go on because we have a really full agenda today and we want everyone to have a chance to speak. We've got just a couple of in-person sessions and the rest are presenters. The rest will be online. For those of you in the room, you can see everything on the screen. Just another note, we're going to hold all the questions to the end if we have any time, just to make sure we get through our long list and everyone gets a chance to present. So with that, I'm going to invite Robert to come forward for the first presentation. And as with all of our speakers, when you have 30 seconds left, Amanda will let you know. And she will also let you know when you're to the end of your time as well. So, Robert,
cool.
Please.
Thank you so much for having me. This is my first lightning talk ever, so I hope to do myself proud. So today I'm going to talk about the Climate Change Society program. We are housed at the Marine Earth and Atmospheric Science department, and I guess it's a nice way to start this series of talks today, since if you look at just the breadth of variety in the different subjects that we'll be dealing with today, we're kind of covering many different sectors of society. And I had one former student tell me when he was talking about our program, saying that with climate change, it's really going to be a part of everything and everyone, no matter who you are or what you do or what the next step in your career is. Climate change will be a part of it, and that is why we're here and why we do what we do. So I wanted to just go over some highlights. We're a one-year master's program. We do have a 4-course certificate that can be taken all entirely online. And we have a multidisciplinary curriculum, and we often have a lot of guest speakers in our classes, anywhere from the state climatologist to folks from nonprofits in Washington, D.C., and researchers in Puerto Rico. We have our Applied Climate Experience. That's our capstone project. Our courses are in-person and online. Every single one of them, so we're going to try to bring the entire program online to be in parallel with our in-person program. We also have part-time option available for folks who decide I don't want to do it in 1 year. We have plenty of students that head in that direction, especially if they are they work full-time. And we have a lot of student diversity and jobs so far in multiple fields once they have graduated. Some of our partner institutions include the Climate Adaptation Science Center, which we'll be talking here today also. Yes?
30 seconds.
30 seconds, okay. And I did want to say that some of the relevant research for us today, kind of want to point that out, like extreme rain and sea level rise in Nag's Head, environmental advisory boards, daily minimum temperatures in public health, GIS mapping and potential geological sequestration areas, and many other subjects that you guys are probably familiar with. And we have resources, we have data, and we just want to be a part of this community. Thank you.
Thank you.
Next, we have Hamid Krim.
May I take off this contraption?
While you're talking.
Yeah. All right. So, do I have to do something? Okay. All right, my name is Hamid Krim, and I'm here on behalf, of course, of my lab, Vision, Information, Statistical Signal Theories and Applications. And this work, primarily funded by the department, is joint work with my graduate student, Tanme Asana, sitting here, as well as Dr. Shea from NC State. So, of course, I want to keep to my notes rather than my slides so that I make sure that I get it on time. We study hurricane prediction and the factors of hurricanes. And hurricanes, of course, that don't only carry the fright factor that's instilled in most of us when they come, but they're very important factor in the health and sustainability of the coastal regions. The changing conditions can actually, environmental conditions can take place in a cascading effect, some of direct impact and others indirectly and long term. And of course, as an example, you have, for instance, destruction of seashore life like oyster beds and crab habitats, which in turn, of course, affect the larger marine creatures, floodwaters of hurricanes, which can ruin ocean water. And I need not get into the history of some of the recent hurricanes that took place here in the U.S. that have landed, of course. And bottom line is predicting hurricanes and hurricanes risks and factors can be consequential in many ways, not only in saving lives, but also in planning, structural planning, as well as planning ahead for measurements that can help us understand better and cope better for the sustainability of the coast, the coast. Our work comes in, of course, from a data science point of view. This is the machine learning point of view, in the sense where there is plenty of data that's taken, that's measured for hurricanes, and our goal rather is to take this data in sort of in a comprehensive and a unified way to understand the dynamics of the complex, I should add, the very complex dynamics of hurricanes, and be able to not only predict the occurrences, but also be able to understand the nonlinear interactions, which are extremely important. As we do here, for instance, we take multiple scales of both temporal and spatial nature. And this is a very recent paper that we published whereby...
Thank you, Dr. Krim.
Yes.
Sorry, I need to cut you there,
Okay.
but thank you. And we will share the
Yeah.
slides.
All right, very
So-
good, thank you. Yeah.
Just there.
Hi.
We'll just make sure everything's set up here. Sorry, next we have
Okay.
Dr. Raju Vatsavai.
Can you hear me?
Yes,
Oh,
you
okay.
may begin.
Okay. Good morning, everyone. My name is Raju. I work at the Computer Science Department and Center for Geospatial Analytics. Today, I'm going to talk about briefly about our research in using edge computing for doing real-time knowledge discovery from spatiotemporal data. Next slide, please. Yeah. Every one of us is familiar with the traditional analytics based on centralized learning from the data that is aggregated over time in the cloud or in your local computing environment is inefficient for real-time processing or real-time inferencing. So analyzing data streaming from multiple distributed sensors in real time requires new thinking, new hardware, and new algorithms. Edge computing is transforming the way to do these tasks, especially handling data streaming from distributed sensors or large geographic regions. And processing the data at the edge also has other advantages, like reducing latency and making connected applications more responsive and robust. And we are all familiar, right? Nowadays, everyone is familiar with the on-device machine learning. For example, I'm assuming every one of us asked our smart speaker, for example, say, what is today's weather? Or asking our remote to change the channel on your TV. Of course, I'm not going to talk about those. So I'm going to talk about the diagram which is shown on the slide, which is focused on real-time analysis of spatiotemporal data that is being acquired by drones or other field sensors through analyzing that data through low-powered, small-sized, low-cost, embeddable supercomputing chips. These are like 1 teraflop, 10-watt power supercomputing chips that you can embed directly in the device that, like, for example, drone or tractor in the field or field robots. Okay, so that is the vision. And we built proof of concept. We built this system and showed that it is highly scalable. In the next slide, I'm going to show some motivating examples. I don't have to describe them, but all of us are familiar working in these domains. A lot of us are working already.
30 seconds.
Top left is an agriculture application where you want to identify in real time if the weeds are growing. And likewise, assessing damages like coastal erosion or damages to buildings or damages to other natural resources like forests. All these have real-time needs, and the proposed framework can take care of real-time analytics. Thank you.
Thank you, Dr. Vatsavai. Next, we have Paul Liu.
Hello, my name is Paul Liu. Next slide. So I'm a custodiologist at MEAS here. So in the past 800,000 years, remember 800,000 years, the CO2 concentration in the atmosphere is changed between 180 ppm to 280 ppm. Remember, this is 800,000 years history. The CO2 kind of up and down, but still in the bracket 180 to 280 ppm, never over 300 ppm. Even, we have the many glacial and interglacial cycles. But since it changed, since the last 1950, 70 years ago, as you can see here, suddenly the CO2 is more than 300 ppm. And 2018 even reached to 407 ppm. Next. So 19, as you can see, the summer reached to 411. Last year, the summer reached 414. This year, the summer almost 417. As you can see, every year is about 2 to 3 ppm increase. Next. As a result, the global warming and the glacial is melt. Next. In 2019 alone, the Greenland lost 600 billion tons of the ice. Of course, next. This is only one consequence as a result. Next is this is the satellite data. Can you go back? Okay, this is the satellite data show the most recent sea level change. As you can see, it's 3.4 millimeters per year. But for North Carolina and Virginia, Mid-Atlantic area, next. So this is based on the satellite and the GPS data. As you can see, the post-glacial rebounding in Canada still about up to 10 to 15 millimeters per year. But if you look at the east coast of US, the Middle Atlantic, we have 2 to 3 millimeters subsidence, 2 to 3 millimeters.
30 seconds.
Subsidence rate per year. So in this case, this is where we make our local area sea level up to 5 to 6 millimeters per year at least. So here I use the GIS remote sensing INSA and the geophysical tool to understand the coastal erosion and the subsidence and those change. So I'm looking forward to this coastal resilience initiative. Thank you.
Thank you. Next, we have Roy He.
Thank you so much, Amanda. Can you hear me? Can you hear me now?
Yes, you may begin.
Wonderful, thank you. Hello, everyone. So my name is Roy He. So like Paul, I am also a faculty member in the Department of Marine Earth and Atmospheric Sciences. So I lead a research team called Ocean Observing and Modeling Group, so OMG. And our teams works on observing and predicting historical, current, and future ocean conditions with expertise spanning from ocean circulation dynamics, marine physical biogeochemical couplings, air-sea interactions, satellite oceanographies, numeric modeling, and also data simulation. We also work on designs of ocean observing system. Some of our specific research efforts, including climate downscalings, focusing on the Gulf Stream circulation dynamics and sea level rise. And we also work on storm impact studies using air-sea wave coupled marine forecasting modeling system that we have developed. We also work on harmful algal bloom population dynamics, the land sea coupled ecosystem dynamics, and finally also working on marine renewable energy resource assessment. Next slide, please, Amanda. So I'd like to just highlight two projects that started very recently. The first one is the NSF funded institute. This is an institute on artificial intelligence for weather, climate, and coastal oceanography. And I'm the co-PI of this large institute that consists of multiple academic institutions, government labs, and also industry partners. So we are working to develop a strong program to link research in trustworthy AI, environmental science, risk communications, as well as workforce development. Specifically, we're focusing on develop trustworthy AI and machine learning augmented prediction system for ocean currents and also for compound floodings. The second program is a NOAA-funded integrated ocean observing system project. We'll be working with other partners in the Southeast US in the next 5 years to develop an integrated ocean observing and prediction system to deliver actionable coastal and ocean information for high quality science and observation.
30 seconds.
So if you're interested in learning more of these programs, please feel free to contact me at rhg@ncsu.edu. Thank you so much, and I look forward to the opportunity to work with everyone. Thank you, Amanda.
Thank you. Next, we have Daniel Obenour.
Thanks, Amanda. Can you hear me?
Yes, we're good.
Okay, great. My background's primarily in environmental engineering and water resources modeling. I started at NC State in 2014. And one of the first projects I got involved with was a water quality forecasting study for the Neuse River estuary. And so if you're familiar with the Neuse, you know it's had a lot of water quality problems and it continues to have fish kills in most years. So if you could advance, the first thing that we did was we created a mechanistic model for all the processes controlling the dissolved oxygen and developed this in a Bayesian framework. So we integrated, about 20 or 30 years of data. And then based on that, we were able to develop forecasts, if you can advance. And so here's an example. This is for 2018, where we forecasted severe hypoxia for the Neuse River estuary due to high flows and nutrient loading. If you could advance it. Thanks. And yeah, there's a lot of advances in this. So here's our forecast. So very low dissolved oxygen levels. Please advance. And so here you can see the actual observations from this year. And so you can see in general, oxygen levels were extremely depleted in 2018. But you can also see some high values. And so what we did at the end of the year is we went back and we ran a retrospective hindcast. Advance that, please. And so here you can see, that we were able to capture those observations. And so that some of this is related to these extreme events, these hurricanes that can temporarily re-aerate the water column, but then lead to, more severe hypoxia over time. Next slide, please. So I just want to, mention a few other studies that we've done and that, I'd like to continue in the future. Some of this is related to modeling watersheds, that are contributing to our coastal areas. So this is for the Neuse, the Tarpam, and the Cape Fear. And so here we develop a Bayesian hybrid watershed model where we're looking at how nutrient loading is changing over time along with retention and how the different source categories are changing over time. Next, please. And so another thing that we're doing is algal bloom prediction. And so this figure is from Lake Erie, where they've had the severe cyanobacteria blooms. But we've also done some work in the Neuse River estuary and also for some of the reservoirs in North Carolina. Next, please.
30 seconds.
Oh, thanks. And then finally, we've done a lot of work in the Northern Gulf of Mexico looking at the hypoxic zone. So this is something that occurs in the bottom of the water column, so you can't measure it with remote sensing. So we developed a space-time geostatistical model to estimate the area and the volume of the hypoxic zone over time. And then we link that to a forecasting model to look at climate change and nutrient loading effects. And then in the future, we're working on linking this up with fisheries models to provide an outlook for fisheries managers over the summer.
Thank you very much. Next, we have Orlin Velev.
Okay, I hope you can hear me.
Yes, thank you.
I'm a faculty from the Department of Chemical and Biomolecular Engineering, and it is really a pleasure to connect to this community. The project that I'm presenting is part of the larger scale research grant, which is mentioned on the next slide. NSF has this EFRI program, which essentially seeks to find new future kind of like highly innovative, even if a little bit kind of like ahead of their time, solutions based on multidisciplinary research of environmental and other problems facing society. So in that regard, we have teamed up with a number of professors who are listed here, and we received one of those awards with our ideas of handling microplastics pollution. Obviously, there is no much need to tell the audience here how important this problem is and how hard this is to tackle. How do you remove all that microplastics that have been released into the world oceans and is really creating horrible environmental problems? So our team consists of 3 professors from NC State University, including my colleague Carol Hall and Nathan Crook, and 2 professors from Cornell University. The general idea here is the following, that if you want to remove microplastics, you cannot really filter or centrifuge the sea. You really have to come up with new environmentally safe way of removing those particles. We are working on the development of what we call active microcleaners, which is if you press once, I mean, should appear kind of as a box, active microcleaners for removing the microparticles from seawater. And then the idea about the whole project of reprocessing is to collect the scum that has been collected on the surface, put it in a bioreactor, process it by using the methods that are developed by my colleague Nathan Crook, process it into biopolymers and biofuels, and use the biopolymers to make more microcleaners. In this way, make a circular process that will be collecting and bioprocessing the microplastics from the sea without really kind of like having to take all that water in and do something about the water.
30 seconds.
If you go to the next slide, this illustrates, and maybe press once more, this illustrates the project that my group is developing. We do microcleaners out of chitosan, which is itself is a byproduct of processing sea crustaceans. Those microcleaners can move on around the water, can capture microplastics, and can float up. The SEM illustrates all the particles that have been collected just by one single chitosan particle.
Our next presenter, Eric Edwards, is unable to join us today, so we ask that you stay tuned. He will be joining us in our October presentations. So next, we have Ayse Ercumen.
Hi, yes. So I'm Ayse, and I'm an assistant professor in the Department of Forestry and Environmental Resources, also a core member of the Global WASH Cluster. And my talk today is about oceans and human health. Next slide, please. As much as we love playing in the ocean, it's not always safe to do so. Next, please. Coastal waters receive fecal waste from wastewater treatment plants, which can be treated or untreated. Combined sewer overflows deliver large volumes of untreated wastewater into oceans during heavy rains. And oceans also receive fecal input from urban and agricultural runoff, from domestic and wild animals, think dogs, and seagulls, and swimmers themselves. Next, please. So swimmers can ingest fecal pathogens from the ocean when they swallow water. Next. And one particular group of microorganisms that we're concerned about, or that I'm concerned about, are antimicrobial resistant bacteria, because infections caused by these organisms do not respond to antibiotics and they can lead to serious illness and death. Next, please. In fact, antimicrobial resistant bacteria have been detected in coastal waters, both in the US and elsewhere. Next, please. And we know from decades of epidemiological research that going in the water increases the risk of enteric infections, but the risk of acquiring antimicrobial resistant infections from ocean exposure is currently unquantified. Next, please. Given that there are more than 2 billion beach visits in the US per year, this could be a significant route of exposure to antimicrobial resistance among US populations. Next slide, please. One particularly vulnerable subpopulation that we're concerned about is young children. Next. Because children spend more time in the water, they swallow water more frequently and in larger amounts. It can be up to 4 times as much as adults. Next. We also know that children experience the highest burden of enteric infections from water recreation among all age groups. And antimicrobial resistant infections among kids is of particular concern because, next slide, because there are fewer antibiotics as is that are approved for children's use. Next. And children also have a higher risk of infection from higher risk of death from antimicrobial resistant infections. Next, please. Therefore, the research question that I'm interested in exploring, hopefully in collaboration with some of you, is what is the risk of acquiring antimicrobial resistant bacteria among swimmers at North Carolina beaches, including vulnerable subpopulations such as children? Thank you.
Thank you very much. Next, we have Aranzazu Lascurain.
Good morning, everyone. Yes, my name is Aranzazu Lascurain, and I work for the Southeast Climate Adaptation Science Center. My role there is Assistant University Director. Next slide, please. Thank you. And I'd just like to talk to you quickly about a unique philosophy under which we work here at the center. And it is one that is growing among different institutions, especially in federal agencies. And so we think a lot about the danger of developing brilliant work to questions that no one cares about. So for this reason, we work in very much applied co-production space. In this image, you'll see that a lot of information is packaged up just like in a FedEx box and thrown over to someone's property. And the idea is, the hope is that someone will make use of the information inside that box. But oftentimes we stop right at that fence line. Next. And so it really is a new paradigm for climate adaptation for ecosystems. And to give you a little history, these climate adaptation science centers, there's 9 of them now. They were established under secretarial order in September of 2009. And the idea is to address impacts of climate change on America's water, land, and other natural and cultural resources. But the imperative is that we must, as scientists, work in tandem with those managers who are confronting climate change impacts. Here you'll see a map of our footprint. We have a lot of coast, but we also have interior lands, a lot of which flow to the coast. But I'd like to point out that we have 5 university consortium members that are part of the center, and that's University of Florida, University of South Carolina, Duke, Tennessee, Auburn. And I want to also point out that we include work in Puerto Rico and the US Virgin Islands. So I invite anyone that's working in these spaces to please let us know, contact us. I've listed here our URL so you can find more about our science. We run an RFP, a request for proposals, every year, about $1 million. It might be going up with new budget increases. But again, I wanted to emphasize that we work in this ecosystem space of both for natural and cultural resources. Next slide. Oh, you might have to advance fully, Amanda, to get all the icons in there. Thank you. Thank you so much. I wanted just to point out how we work, a visualization of how we work to help you wrap your head around this. So we'll start at number
30
1.
seconds.
Thank you. We work with natural resource management agencies, both federal, state, and tribal. We work, then they bring their questions to us and our consortium members, and we work with the USGS scientists that form part of our center. And we co-produce and work on a management problem. And that's part of the co-production process. And it can be very iterative. And then we transfer that adaptation strategy back to our coworkers, our partners, federal, state, and tribal agencies. Thank you.
Thank you.
Good afternoon, everyone.
Next, we have Brian Bell.
Good afternoon, everyone. My name is Brian Bell. I'm an associate professor at the School of Architecture. I'd like to take this opportunity to introduce you to a sector, a focus area we have here called public interest design. We have a very vigorous coastal resilience program as well, but public interest design is a broader umbrella. And the premise of public interest design is comparable to public health, that we feel that there are multiple issues that communities deal with, and there's the possibility that design can play a role in those solutions. So we approach every community with a blank slate. We say, what are your challenges? What is your vision of success? How can we work together? We find stakeholders. We send our students out to meet with people. They were at a fire department barbecue on Saturday, interviewing people. But it's a high equity, high engagement process. Now, not surprisingly, one of the main issues that many of our communities in North Carolina deal with is disaster response and resilience. And we started working in Pender County, which is associated, you may know, the beach area of Topsail, but inland there's what you might call an asset desert. Most of the resources are focused at the beach. And you see the beach here in red. What you see associated with the blue dot is a community hospital that's in jeopardy. And you see the white dots, which are fire stations. Next slide, please. So what we've started doing is working with the fire stations to bring in additional services, including disaster resilience. And even though these are inland, they flood and are often cut off by any help or roadways to get to other shelters. So we're working in a town called Atkinson with the fire department there. We're looking at multiple flex spaces. How can this building be used as a community service, fire department day to day? And after a disaster, it all flips seamlessly to disaster response. They're really, like most of our communities, very unprepared for disaster response. Last hurricane, FEMA set up in a tire store. So you can see a lot of the activities. We try and arrange as many activities as possible for these. And so that's our approach to disaster resilience in Pender County.
30 seconds. Sorry, thank you. Next, we have Matthew Ricker.
Thanks. Yeah, I'm Matt Ricker. I'm assistant professor in the Department of Crop and Soil Sciences, and I'm just going to talk a little bit about some of the research that we're doing with soil survey in the coastal zone of North Carolina right now. We've identified about 2 million acres that need reclassification mapping as far as soil science is concerned, and there's a desperate need for updated interpretations, including those with salinization and coastal issues like flooding that are becoming more prevalent in the coastal zone. Specifically, I'd like to highlight a few projects that we're working on through the National Cooperative Soil Survey, which is part of the USDA NRCS. And those are mostly looking at interpretations environmental interpretations for coastal zone blue carbon storage, looking at soils in particular. We're doing saltwater intrusion work, looking at tidal swamps, ghost forests, and our marsh transitions and our tidal wetland systems. We're also looking at coastal inundation and what's happening as sea level is rising and inundating our subaerial or under air soils, and they're becoming subaqueous. The photo on this slide is the first subaqueous soil cores for classification that have been taken in North Carolina that was taken last year. We're also doing some work with coastal septic system functionality in relation to soil properties and sea level rise. So there's a large umbrella here. If you're interested in sort of soil issues or you have soil issues that you'd like to collaborate on, I'm the Southeast Regional Coastal Zone and Subaqueous Soil Committee Chair. And then Greg Taylor with USDA NRCS is also here in Raleigh. He's the co-chair with me. Next slide, please. I'd like to also highlight some ongoing work, new initiative through CALS, which is climate adaptation through agriculture and soil management, short CASM. This is an interdisciplinary climate change initiative looking at ways that we can mitigate greenhouse gas emissions and store carbon specifically with soil management. And I'm the saltwater intrusion lead for this project that's internal to NC State, and we're looking specifically at agricultural lands. We're doing a number of different field and laboratory soil studies. This photo here is a drone footage from Hyde County, North Carolina, showing the Pamlico Sound and then the damage to crops. This is soybeans and cotton that are heavily damaged by salinization and coastal flooding. So we're planning on doing field and laboratory studies actually starting tomorrow. We'll be in the field looking at mapping soil salinity, soil health and carbon storage, greenhouse gas production, including methane, carbon dioxide, and then eventually making risk maps and extension materials from this. So if you're interested in these types of initiatives that we have, you can visit the website at chasm.cals.ncsu.edu. And if you're interested in what we're doing real time, you can check out my Twitter handle at MuckDragon. Thanks.
Thank you. Next, we have Chuck Flink.
Thank you, Amanda and Mary. First slide, please. Watersheds are fundamental landscapes of our temperate broadleaf forest biome. Yes, they are classically defined as catchment areas for drainage. However, watersheds are so much more than the sum of their water catchment and conveyance parts. The landscapes within watersheds influence the quantity of water flow, the quality of water, water temperature, non-point and point source pollution mitigation, biodiversity, economic vitality, and resource exploitation and conservation. North Carolina watersheds have unique catchment and conveyance dynamics that must be more clearly modeled and understood, especially in the face of rapid climate change. Watersheds should be the basis for crafting resilient community planning, design, and mitigation strategies. Next slide, please. North Carolina watersheds that span the coastal and Piedmont geographic region influenced European settlement patterns and the resulting communities that we inhabit to this day. Historic settlement patterns of Eastern North Carolina communities were based on access to main stem rivers, the critical transportation corridors of 18th and 19th century North Carolina. Settlement patterns changed dramatically as migration moved west beyond the fall line, which is shown in red. It is critically important that as we contemplate how to make coastal communities more resilient to the impacts associated with climate change, that we account for the unique geology and geography of North Carolina. We are not going to solve coastal resilience problems by focusing our efforts exclusively on the impacted coastal plain communities of Eastern North Carolina. We must expand our focus to all of the landscapes within a watershed and how this collection of rural, suburban, and urban landscapes contributes to and therefore becomes part of the solutions to coastal resilience strategies. This is going to be challenging undertaking for North Carolina, as we will need to overcome political and societal resistance to large-scale thinking and watershed-based solutions. Thank you, Amanda and Mary.
Thank you, Chuck. Next, we have Mike Burchell.
Good afternoon. I'm Mike Burchell from the Department of Biological and Agricultural Engineering. Next slide, please. 15 years ago, a team of faculty and graduate students from NC State teamed up with the North Carolina Coastal Federation and the Division of Mitigation Services to create one of the largest constructed tidal salt marshes ever in North Carolina at North River Farms near Beaufort. The tidal marsh was built on farmland that was strategically located adjacent to the North River estuary and just downslope from Open Grounds Farm. This tidal marsh is 35 acres and contains over 5,000 feet of tidal streams. To build it, the elevation of the former farmland was graded to tie in with the surrounding marsh systems and then planted with 150,000 salt marsh plants. We've been very fortunate to conduct over a decade of research at the site, and these are a few of the major findings of our work. First, it was a great design. The structure of the marsh remains stable and it survived many tropical systems. On several occasions, we've measured floodwaters up to elevation 4 feet before the water slowly was released. Secondly, the marsh was built downstream of farmland to intercept some agricultural drainage. Since tidal marshes are such dynamic systems, we had to develop some technology to provide precise, continuous monitoring in pretty inhospitable places to measure flow and water quality. We found out as much as 25 to 40% of nitrate retention by these systems during storms, but overall about 10% reduction due to occasional flushing events that seem to offset these removals. Third, wetlands are often cited as a greenhouse gas emitter, particularly methane. Using gas flux chamber measurements, we were able to show that in fact, methane emissions in this salt marsh were very low due to high sulfate content in the tidal water. So having low methane was really good news when considering new carbon storage in the marsh. To determine whether the marsh sequestered carbon, we measured carbon that was lost from the system in gases or carbon in outflow water, and carbon that entered the system in organic soil deposition above ground and below ground biomass. The result of carbon in minus carbon out was a net carbon storage in the system of about 90 grams per carbon per meter squared per year. And finally, with increasing rates of sea level rise, how long will these services that the marsh produce last? So using sediment elevation tables and feldspar markers, we found that the marsh elevations in most locations were actually increasing at a rate that exceeded or equaled local sea level rise. So the marsh should remain in place to provide these resiliency services for another couple of hundred years if those rates continue. So we hope that our lessons learned can guide future tidal marsh projects to help build resiliency on the coast. The North River Wetlands Preserve is still actively managed by the North Carolina Coastal Federation, and I invite you to reach out to our team for new research partnerships at the site. Thank you very much.
Thank you. Next, we have Fred Cubbage.
All right, thank you. I hope I can be heard. I'm sure somebody will tell me if I'm not. So appreciate the opportunity here. And really, I'm representing a team of various persons, individuals, and departments here at NC State University, including the Department of Forestry and Environmental Resources and the College of Natural Resources, the Sea Grant and Bioag Engineering, and the College of Design. And we have external partners, especially with the North Carolina Foundation for Soil and Water Conservation and the Environmental Defense Fund that have worked on these projects. We do have funding from the North Carolina Policy Collaboratory and the Environmental Enhancement Grants from the Department of Justice as well. Next slide, please. So really, the idea behind these is to think that actually it's rural lands that are not only perhaps affected to the greatest amount to some extent in the communities downstream, but also offer at the landscape scale some of the greatest opportunities for really mitigating and adapting to climate change. So we've had a project that's continuing to look at ways that these rural communities and farmlands and forest lands in particular contribute to really what's called flood attenuation, right? Which is basically storing floods and floodwaters over time and releasing it more slowly, essentially at a different scale on the hydrograph, really, a later release perhaps than the direct floods. So the first thing we did was try to identify the practices that are most likely to be useful at the landscape scale on rural lands. And we categorize these into three broad groups that are really a continuum, but they certainly start with conventional agricultural practices, which can be modified to enhance water storage capacity on farmlands and forest lands. And you can see the list here. These include cover crops and no-till, breaking up hard pans so that we have better water infiltration, afforestation, with forest absorbing more water at a greater rate and releasing it more slowly. Agroforestry, which combines pasture and forestry to a large extent and has similar benefits. And then we have ones that are perhaps wetland and stream restoration, which may be partially construction and partially natural-based solutions. And then also water farming, which is really much more perhaps a construction-based, but still natural solution to these flood events. And each of these has varying levels of opportunities, amount of water that it might store, and costs that it might incur in order to be implemented. So next slide, please.
And 30 seconds.
And so what we did here was estimate the cost of these different practices. You can see really the idea here is how much does it cost to install a practice? And then if we want farmers and forest landowners to implement these practices, how much would it take for us to be able to subsidize those practices or essentially pay for them to install the practices on their lands? And of course, the numbers in red are those costs. Excuse me. And basically the idea is how much would it cost to put these all together? And we're working on that in the future. Thank you. Thank you.
Thank you. Next, we have Sarah Shashani.
Hi, everybody. My name is Sarah Shashani from the Department of Industrial and Systems Engineering, and with colleagues from Biological and Agricultural Engineering and Marine, Earth, and Atmospheric Sciences. We've been studying the impact of climate change in animal agriculture productivity. So what we know is that with warmer temperatures, animals can have thermal stresses, and with excessive rainfalls and extreme weathers such as flooding and hurricanes, there will be a risk for manure storage structures, spillovers, death of animals, or disruption of routes for feed transportation to the farms. So in general, as a step one for this big ambition, we've been looking at the Hog Lagoon spills. The figure you see on the lower left is the Eastern North Carolina after Hurricane Floyd in 1999, where there was disruption in the hog operation and due to the heavy rainfalls, and as a result, there was negative impacts on the water quality and sustainability of those farms. In addition, that could also impact the crops and the animal feed. So our goal in step one of this project is to find ways to predict the probability of lagoon levels exceeding the maximum storage capacity, as well as the ratios of the nutrients in the water. Please, next slide. So we've started working on this as a purely data-driven framework where we've collected, we're going to collect the records and data on the lagoons, animals, and climate. And the idea here that we have is to combine domain agnostic framework that's data-driven with the domain-informed. Here we have some responses that include lagoon integrity and nutrient ratios, but we can also have
30 seconds.
In extension of this, we can include animal productivity and other vulnerabilities due to climate as our responses. So we are interested in meeting experts in crop and soil hydrology and agricultural economics for an extension of this for a more comprehensive assessment of animal production resilience. Thank you.
Thank you. Next, we have Rod Rejesus.
Hi, good afternoon, everyone. So I'm Rod Rejesus. I'm professor and extension specialist at the Ag and Resource Economics Department. Next slide, please. So what I'm going to talk a little bit about today is just my current research on saltwater intrusion. So the main objective of the work that we're doing right now is to determine farm level economic impact. So I'm an economist by training, so we're interested in economic impacts of various phenomenon. And in this particular case, looking at saltwater intrusion in coastal agricultural lands. And the specific interest is in the productivity, yield, or profitability impacts of saltwater intrusion. And we have selected farm fields in Hyde County to sort of try and analyze the economic impacts of saltwater intrusion. And one of the main questions that we're wanting to look at is, with the expected sort of negative impact of saltwater intrusion, will it be better to just abandon the field and convert it to coastal wetlands and get payments from conservation programs? So that's why it's important to see whether the economic impact is really negative, and it's better to just abandon the land and convert it to wetlands and sequester carbon. Next, please. And this is in collaboration with Matt Ricker, who presented earlier, and that CHASM initiative that, that I'm part of. Next slide, please. But one thing that I want to build on from that current research is to just increase the geographical scale. So for the current research that we're looking at, we're just looking at selected farmer fields, collecting data on saltwater intrusion and so forth, and yield and these kinds of things to determine the economic impact. But I think it's important to see sort of a wider scale. So for example, throughout the coast in North Carolina and the mid-Atlantic and so forth, to determine sort of, well, how big of a problem is saltwater intrusion in agriculture? And this may require sort of maybe panel data, county level analysis on saltwater intrusion, but I'm having difficulties essentially finding data that could sort of proxy for saltwater intrusion levels at the county level, for example. Perhaps some researchers here in the community have some ideas on remotely sensed data that could indicate levels of saltwater intrusion for a wider geographical scale. Next slide, please.
And
so
30
that's
seconds.
what I'm interested in. So if anybody's wanting to work on sort of coastal agricultural lands, also its interaction with adaptation strategies. Fred talked about cover crops and no-till. These are adaptation strategies as well, seeing how that interact with the economic impact of saltwater intrusion. That's all I have. Thank you.
Thank you. Next, we have Alpir Boskurt.
Hi, everyone. Next slide, please. I'm a professor in the Electrical and Computer Engineering Department and also representing the Ayse Center in the Centennial Campus. We focus on low power sensors, and we try to put these on different biological organisms to coin what we call the Internet of Things to generate out of the box novel phenotypic data. In a nutshell, we try to instrument animals and plants and perform behavioral and physiological sensing, especially to monitor the stress response coming from these organisms. We also try to combine this with custom environmental sensors for air quality or soil sensing to correlate the health of these animals with the environmental factors to correlate the health and exposure to each other. In the top middle of the slide, you see some of our research products. You see there a subcutaneous injectable capsule that we designed for fish or other animal like pigs and etc. to do heart rate, body temperature, and activity level monitoring. We also have starting research on another version of this to do microbiome sampling in the GI tract of the animals. On the top right, you see a nanocellulose electrode. This is something that we test with Dr. Michael Daniel from my department to look at electrophysiology of plants. We do surface recordings to understand and track the plant stress due to the environmental changes and anything that would create an environmental stress. The project that I would like to highlight here is the one in the bottom in collaboration with Professor Jay Levin, where you use inertial measurement systems attached to the muscles to monitor their gaping behavior. This generates data and a metric not only to monitor their health, whether they are in a wild animal or in an aquaculture farm, but also this gives us an idea about the gaping behavior gives us an idea about the any indication of environmental pollution. So this is kind of using the animal as a sensor itself. So these are some conversation starters, and we'd like to, we would be glad to explore any out-of-the-box sensor ideas you would have. And
30 seconds.
My email address is up there. Just shoot me an email. Thank you.
Thank you. Next, we have Benjamin Reading.
Thank you. Next slide, please. I'm Ben Reading in the Department of Applied Ecology, and I work on aquaculture, fish physiology, breeding, and genomics. I'd just like to say that 9 out of 10 seafood products consumed in the United States of America are foreign import, and this has led to a $16 billion a year trade deficit. I work with USDA and NOAA on marine aquaculture initiatives across the country. And I also work to understand genomes and phenomes, physiology and genetics, and breeding and domestication of fishes. I'm the faculty director for the Pamlico Aquaculture Field Lab in Aurora, North Carolina, as well as the faculty director for the Lake Wheeler Field Laboratory Fish Barn here in Raleigh. I'm the National Aquaculture Coordinator for the NRSP 8 National Animal Genome Program with USDA NIFA. I'm also the co-coordinator for the National Breeding Program for the U.S. hybrid striped bass industry with USDA ARS. And I'm a member of the Southern Regional Aquaculture Center for USDA NIFA. Really what we're doing is we conduct congruent work with academic, industry, and government partnerships to really propel domestic aquaculture in seafood production in the United States of America. My species of interest is the striped bass and the hybrid striped bass. And the project I like to highlight here is the Sea Grant, the NOAA Sea Grant Striper Hub, which is one of 17 national hubs that was funded by NOAA last year, that I coordinate with North Carolina Sea Grant. And the goal of that program is to continue to support the U.S. hybrid striped bass industry and as well expand to the culture and commercial production of striped bass in aquaculture practices. I am also a content matter expert liaison from industry to the government. Next slide, please. And I advise USDA and NOAA on seafood production and seafood importation in the United States. I've spoken in the White House, I'm sorry, at the Capitol building. I've also consulted with the U.S. White House. For instance, Executive Order EO 13921 was passed last May of 2020. That's promoting American seafood competitiveness and economic growth for the United States. And this year, I am a member of the U.S. intelligence community. I helped to be a senior author on writing this report for U.S. Homeland Security on threats to food and agriculture resources. That report was submitted to the Office of the Director of National Intelligence earlier this year. And seafood importation is one of the concerns that was listed in there. And so collectively, our work is on securing U.S. seafood supply through production by aquaculture, as well as supporting commercial harvesting. And so I am Ben from Applied Ecology. Thank you.
Thank you. Our final presentation will be made by Carrie Furness.
All right, can you hear me?
Yes, you're good.
Great, thanks very much. So if you can advance. So I am Carrie Furness. I am also in the Department of Applied Ecology, but associated with the Southeast Climate Adaptation Science Center, which you heard a bit about already from our university deputy director, Aranzazu Lascurain. So I'll give a little more focus. Here's a slide for context, and as this sort of message about solving the wicked problems. In this case, I'm focusing in on the fact that this is a collaboration of university and federal researchers. So it's focused around actionable science, however, that does meet the needs of natural and cultural resource managers. So USGS funds the federal side of this, and this research paradigm there in the middle, sort of how the research is focused. Exposure, what does climate and land use changes look like on a given landscape? Impacts, what are those impacts of those stressors on ecosystems? And adaptation, how can we make climate smart decisions in light of those impacts? So USGS does fund a fair amount of research focused on coastal areas. So I would point you to our website there, the ccask.ncsu.edu, to get more information. Across the bottom of your screen and then in the map, you can see the federal university partnership aspect of this. So, and this plays out in large part through our host award in supporting of working groups. And those are led by some of our consortium university leads and are geared towards being multidisciplinary and multi-sector. So crossing boundaries of agencies and both federal and levels of agencies, I guess, levels of governance. So, and they are to identify and address regionally relevant emerging issues and then try to develop some syntheses that would feed back to USGS to inform science that might be done. So if you want to advance to the next, I want to give you a focus here on a particular working group, which is the Coastal Resilience to Global Change working group. And you can see this is a snapshot of our of the website, which is up on the top. So all of this information is available there. I encourage you to dig into that a little bit. But again, this working group, each working group sets its own goals. And in this case, trying to identify the needs and the gaps and opportunities for coastal resilience in the Southeast US across research at the universities, nonprofits, federal agencies, and some of the other folks who we've heard. In backtracking a bit, I do want to say that some of this is representing here our university.
30 seconds.
Sorry. And, but we also have some faculty affiliates. So you can see the leads there are Karen McNeil, Auburn, Lydia Olander, Duke, Michael Allen at University of Florida, and myself and Mary Watson help coordinate the NC State component of this. So there are some products that come from this working group. One is this Coastal Resilience database, which you can find at that link. And then there are a couple of reports, and I would call your attention to both of those. One is sort of a research priority white paper on developing some system modeling. And the second is a really nice effort to pull together some work about some case studies in the Northern Gulf of Mexico. So thank you.
So that was an amazing first array of work that everyone presented, and it's super challenging to condense your ideas and interests into just 3 minutes. But it was a little bit more challenging at the beginning, so I'm going to invite Hamid to just finish up a few comments. I think you'll have to come up here because those mics aren't working. And then I'll just wind it up.
Well, really, what I wanted to say is basically anybody who's interested in pursuing either the physics or the chemistry of these processes that take place on at least that pertain to this resilient and sustainable coastline is very welcome. We look at basically from really fundamental to applied questions, and we have what I like to think as a principled way to data science. We are not afraid of mathematics. We like that, and we also like the physics as well. And at last, I'm not only actually sort of here promoting the research. I'm also a believer, as the ad goes. I'm not only a user, but I'm a client. Okay.
Thank you, Hamid, and thank you, everyone. That was really amazing. And again, hopefully it just gave you a little bit of an introduction to what our presenters today are doing. We are going to post the recording of this session on our website. So if you missed something or you want to get the email addresses of our presenters today, and we encourage you to reach out to anyone whose work excited you to make connections. We have one more session coming of lightning talks. That is, we have multiple sessions still coming, but we have one more session of lightning talks coming on October 13, and we have 1 or 2 spots still remaining open there. If anyone hasn't signed up and would like to present on October 13, please go to our website, fill out the form, and Amanda will work you in. And I want to thank Amanda Mueller, enormously. It was a huge lift. to get all these presentations coordinated and put together. And I thank her for that. We couldn't have done it without her really hard work. After our lightning talk session, we've got 2 amazing panel discussions planned and 1 more in the works. So we'll take a deep dive into a couple of big, rich areas and more about that to come. And lastly, if you haven't been to our website, please go to our website. There's tons and tons and tons of information. It is very much a work in progress with lots of stuff being added all the time. And I will just say one more time, with a slight bit of trepidation, but we are getting close to being able to launch our directory. So we'll say more about that when we get there. But thank you all very, very much. And I don't know how to manage questions from those who are online, but unless Amanda wants to read the chat, but we'll look forward to connecting again soon.
There's currently no questions in the chat.
Well, doesn't surprise me. We said we wouldn't have time for questions, so thank you. Thank you all very, very much. And take care if you didn't hear that thunder. We are having a thunderstorm right here at Tally, but wherever you are, be careful in the weather today. And thank you.